Hi, everybody. Adam Savage in my cave with a spacesuit part build. We haven't done one of these in a long time. The spacesuits are always percolating in my head in the background. And I have all these plans for spacesuit stuff, but a lot of it's like big long-term projects. I want to make a XEMU, all sorts of cool stuff, but many of the deep dives have to wait until I have larger blocks of time to attack them. However, one just came up. One project just came up, and I'm dying to cut my teeth on it. So the first spacesuit I built myself, the first spacesuit I put together, yeah, that's the right way to put it. The first spacesuit I put together, it was my Mercury suit. And I had a wonderful seamstress here in the Bay Area who did the primary sewing of the suit. I bought a beautiful replica Mercury helmet, and Ryan Nagata accuratized it. I did the boots twice. There's all sorts of little doodads. I did all the hard parts of the suit myself and the weathering. And the gloves were a difficult thing. I made myself a pair of Mercury gloves, and, you know, I'm relatively happy with these gloves as they are, or at least I was, until I reached out to the woman who I hire frequently to make gloves for me, and that is Linda Guaris. She has an Etsy store called Like Linda, and Linda Guaris made me some Mercury gloves last year and had a couple corrections, and I just got the latest pair of Mercury gloves from her, and look at these masterpieces. They are still almost unweathered. I've just done one tea stain pass on the white parts, but and these are going to get a lot dirtier before I'm done with them. But look at these this is masterful work. And once I'm done weathering these, I'm going to have to include a towel so like people are clear that this is a replica. However, as you'll notice, these are missing something that's on these, which is the aluminum connector part. And through a collector who owns a couple of real aluminum wrist rings, I was able to get some genuinely tight measurements. And that's what I'm doing today. I'm going to make the wrist rings for my Mercury gloves. Now, I'm not just making one set. I'm actually going to make 3 sets. So that's 6 rings. And they're couplers. Yeah, it's a lot. I'm actually going to start by making 7 because I'm definitely screwing something up. So we're making 7 rings. And since the outer diameter is 4 inches, I got this big, fat, beautiful chunk of, I think this is 6061. Yeah, it is 6061 aluminum. And I'm about to chuck it into the lathe. And then, yeah, there's a lot of steps to this one. And it's going to include some equipment I haven't used very often, which is there are ridges around the outer perimeter, which means I have to take a ring like this and mill in detents for these ridges for tightening the gloves. And this involves my dividing head and an easy rest on my mill and dozens of passes. It's going to begin by truing this up on the lathe, giving it 2 nice, well-aligned centers. And then once I have that, I'm going to glue this entire thing and lay it out really carefully because I'm going to basically do all of the milling of the ridges on this monolithic block, and then I'm going to chuck it back into the lathe and I'm going to hollow out its center. Yeah, it's a multi-step process. This is likely going to take me hours. But I've been wanting to do these wrist rings forever because my Mercury suit, let's just look at this again. I mean, look, I know this is fine. This is, you know, it sells. It definitely has a feeling and it evokes, but not like this. Not like this. Not like this. That's me doing a terrible impression of Switch. Or is it APOC? I think it's Switch. Anyway, we're going to dress these up with some of their harder parts. Hard to make and made out of hard stuff. All right, let's get started. Okay. One thing that is, working with big monolithic blocks like this, non-trivial. You don't want them to get away from you. think 4 inches is just about the biggest piece of work this chuck will reliably hold. And it's actually, I'm going to check the squareness on its bottom before I do anything. Yeah, that is lovely. Great. I'm glad I have one reference surface. This is within a couple thou across its entire face, which is freaking ideal. Come on. This is one in which I really, super important that it is highly concentric. So I'm going to break out. The indicator, and I'm going to put it on slow speed. I'm going to turn on this magnet. Yeah. Okay. So now I've got my indicator on here, and I'm going to turn it so that it reads me 0. And then oh wow. Yeah. I'm going to spin it. And so, yeah, I'm way out. Properly centered up. I know I should have used the 4-jaw chuck, but I didn't need to be that exacting, and I got it within about 6 thou. Plenty enough for these wrist rings for me. Now I'm just going to face it, and then I'm going to give it a little center hole for, yeah, and I'm going to give it a center hole. So, what is that going to look like? That's going to look like, let's try that. A little bit of artifacting there, but that's just fine for layout. Great. Right, I'm just going to chamfer the edge the tiniest bit so it's not sharp. There we go. Yeah, nice. It's now exactly square on both ends. Okay, exactly is a charged term. I'm going to say it is now close enough to square on both ends, that end and that end. So now it's time to do a fairly hell of a setup, a fairly intense setup on the milling machine. Yeah. Looks like Iron Man is like staring at the milling machine like he doesn't know what to do with it. Well, I mean, he wouldn't, would he? Well, it's just an empty costume, isn't it? Yeah, isn't it? Yeah. This is a, yeah. So this is one of those operations in which I got to pull the vise. And I don't like pulling the vise because I don't like truing it back in. It's 15 minutes. I know. It's not that much, but I got to pull the vise. So that's what I'm going to do. As always, every time you have to pull your vise and you clean and you're freeing up the the bed of your mill is a good time to clean them all out and make sure everything is nice and flat and square. These are the vise. They're just going to live there. This guy, yeah, you're coming with me. Run! Right. All right. Let's introduce you to one of these tools. So this right here is a rotary head for the mill. So when I turn this handle, it's not locked down right now, but if I turn this handle, the head moves, and I can read how much it's moving on the increment dial down here in degrees. It also has a hole plate here for certain divisions. I don't have the full set of hole plates. I plan to make those at some point, just not necessarily super important for this build. But this also has a tilting head. And so what I'm going to do is I'm actually going to place it like this. I'm going to tilt the head down to 90 degrees. Then I'm going to, there we go. Then I'm going to chuck this piece of aluminum into that chuck, and I'm going to support it on the other side with this bad boy. Yeah, all of that is about to happen. And then once I have it supported across that, then I'm going to start making some cuts. But first is the layout. And that is getting this whole thing blue and making the marks and making it really clear to myself, to future me, exactly what I'm cutting away and exactly what I'm leaving. So I ran into an issue in which the jaws of my dividing hand are actually not big enough to grab 4 inches. So I used some of my Deming bits to hog out an 1.5 inch hole here. And I'll use the negative pressure. I'll use the opening pressure of the jaws to hold on to this. And they're built for this. They've got radii on their outside edges. So that should work just fine. I'm not making big, deep cuts in this. If I was, I'd probably open this up to be much wider to give myself a wider base. But I'm literally making cuts that are like all of my final dimensions are within 100th of the outer dimensions of this thing. So it's all very light cuts, very quick passes. Here's hoping. All right. It's time for some layout. This is going to take a little while because, well, there's a lot of moving parts to this, and I want to get it right. So for the uninitiated, layout is a process whereby you mark the piece that you're going to cut with all of your plans on how you're going to cut it. Great. Yeah, nice. I want this surface to be super clean. The cleaner it is, the better my marks will be, and the better my final product will be. Yeah. And Lord only knows, I have certainly screwed up enough space parts by moving hastily to want to move methodically through this one. You know what? I'm going to chuck this into the lathe and hit it with some Scotch-Brite. All right. Yeah, you see the difference. Okay, so now we're going to blue it up. I have grown to vastly prefer the brush-on marking fluid to the spray marking fluid. I find that when I spray on the marking fluid, it tends to go on a little too thick, and it tends to crack around my lines, which is like exactly the opposite of what it's supposed to do. So while I still do spray for big sheet material, the fact is when I'm doing the smaller amounts, I'm definitely going with the brush on. Oh, I should probably check this into the lathe for this because it's so much fun to do on the lathe. Hang on. Yeah, this here. This is like click spring material. Here, watch this. we go. Yeah. Let's let it spin a little longer. Right now, I'm just making a set of reference marks. Here is the 4-inch billet that will eventually be some of my wrist connectors. It is sitting on a dividing head, on a rotary head that is laid down to 90 degrees. I have used an indicator to make sure that it is perfectly level and that it spins within 4 thou of true. That is as good as I'm going to get, and I'm happy with that. I've got an easy rest on the other side. This guy has to stand up on at 3 inches. So I use some 1, 2, 3 blocks to do that, and then I lock it down with the clamps, and the same thing with the easy rest, also locked down with the clamps. When you are clamping up and setting up work like this, you got to go slow. You got to go methodically. You got to just make sure you've indicated every last thing that you can think, because the things that you can be 10 thou out at one end, and it turns out you're 50 thou out at the other end, and like, I can almost see 10 thou. I can definitely see 50 thou. So this took the better part of the last hour, and that's fine. That's exactly what I expect. Then it turns out that I have to cut this little V groove, and that's for these little, there's 11 positions with these 3 little, and I got to cut a V groove out of that at 60 degrees, and that's what that is. That's a standard thread cutting. But I don't have the thing. I don't have a bit that cuts a perfectly angular bottom 60-degree cut. That's 100 thou deep. I've got a router blade which does a kind of what do you call it? A hollow grind. So I'm going to try that. I'm going to run that down the path of this. Like if I totally screwed up, I have a whole second piece of 4-inch that I can still use. And I'm going to be taking notes because whatever operation I'm going to do to get this first pass of the 3 bumps, I'm going to be repeating that operation 11 times. 11 times. Welcome to the 11 times. So, yeah, I think with all that being said, it's now maybe plausibly time for me to get cutting. There we go. Yes, 40 thou is correct. Yeah, it's like, 41 thou, absolutely dead on the money. This is a terrifying cut to make. Let's spin it up. Get it hot. All right, I made my first cut, and it's ass. It's terrible. It's a terrible cut. Plus, here's the problem with a V-groove cut with a sharp bottom, is that the point of any cutter you have at the bottom of that valley is effectively not moving. It's just moving a lot slower than the outside, in the same way that the center of a car tire is spinning at the same amount of RPM, but covering much less distance than the outside of the car tire. Does that make sense? At any rate, this idea of a central cutter cutting each channel, not going to work. Not going to work at all. If you are a machinist with some experience, you were probably yelling at the screen the whole time. I am now going to do something really weird. I'm going to take one of these slitting saws, which is just shy of 80 thousandths thick, which is exactly what I need, and I am going to grind it. I'm going to grind its profile there into a 60-degree cut-ish, using a very precise machine tool known as the flap wheel grinder. Let's get dressed up for the occasion, shall we? Hello. Oh, barely making a dent. I want to spin in the right direction. I want to spin in that direction. Yeah. And then it's self-tightening. Yep. Making some progress. All right, keep trying. Bingo. Okay. So, today is the day of the dropping stuff. And I know it's not recommended. Usually when I drop something more than once, it's a sign I just need to slow down a little bit. Yeah. This ought to work. So for reference, this is a slitting saw. It is a saw blade for the mill for pulling material out in a nice shallow channel, okay? Now I've taken a slitting saw that's the same as that and I've cut it on an angle so now it's a sharp, now it's got this roughly, hang on, let's see here. Yeah, it's got a roughly 60-degree angle. I really don't think any space enthusiasts are going to be checking my angle work there. And this is actually a slitting saw arbor with an R8 bottom. Luckily, the arbor gave me enough room to grab on my lathe here. And the grinder, yeah, did really nice work on, hold on, let me see if I can, there you go. See that? See that chamfer? That's it's a nice straight chamfer. It should give us a good channel. Here we go. All right, let's try putting in this slitting saw arbor and seeing where we can get to. with it. I want to raise this up a little bit. I want as little cantilevered out as I can get away with. So in fact, I'm actually going to move this slitting saw up on the arbor here. Ooh, you won't go past that. Okay, I feel you. All right, I have succeeded in balancing my slitting saw on the arbor. It looks like I'm making a cut. It looks like that cut is real. Let's give this a shot. All right, that's sort of working. Let's keep on going. Okay, hello. I have completed a set of passes on this 4-inch billet. The passes that I've completed are for the little triangles, the 11 sets of 3 triangles that run around the circumference of the Mercury wrist rings. And I'm about to do depth cuts to finish off the outside of this piece, but I wanted to pause here for a second and talk about why I find this particular kind of machining so difficult. The main reason is that I am an impatient monkey wearing shoes, and I like to get things done. And let's be clear about what this took. I had to experiment with the bit. I then had to work with some slitting saws. I then had to figure out how to make my slitting saws fit on my arbor. Then I had to sharpen my slitting saw at a 60-degree angle. Then I had to figure out the correct number of degrees to do these passes. There are 11 groups of 3 triangles each, And it takes 4 passes to isolate those 3 triangles. So that's 44 passes. And I did it twice because the first time I didn't think I went deep enough. So that's 88 passes using this slitting saw here. And every single one of those passes has the potential to ruin this piece. And the simple fact is until lockdown, I was rarely able to get into the headspace of like, this is just going to take whatever time it's going to take. I mean, sure, an excellent machinist or a CNC machinist could get this done in a fraction of the time it's taking me, but that's not the point. The point is, this is what's happening. So yesterday I came in and I was thinking I'd make some wrist rings, but it took me all day just to do about half of the passes on this. This morning I came in and finished that, but I have no expectation about where I'm going to get at the end of today. And that's a big leap for me as a maker. Because, you know, I have get it done-itis. I like to finish every day with a tangible, practical marker of the work that I have done that day. Not every day ends with that. One has to be okay with that. And by one, I mean me. So next set of problem solving is going to happen next. Okay, there it is. This is my billet of aluminum on which I've cut the 11 clusters of triangles plus the middle switch slot. I got to tell you, like, there's lots of little things that are off about this, but I believe I'll be able to adjust each individual one. Again, I'm only trying to make 6 of these. I think I can only get 6. I might only be able to get 4 out of here, and that's fine. If I can only get 4, it's totally fine. But I'd like to get 6. It's time to chuck this thing into the lathe now. Scary. Just to be clear, on this guy, I just made well over 125 passes total over 2 days on this single 4-inch piece of aluminum. That is a lot of machining and a lot of like prognosticating about what's going to give me problems later. But I didn't mess up anything too bad. There are small differences between this and the real thing, but not so much as that anyone would really notice, but me and maybe a few other people. I'm looking at you, Ryan. But that feels like an accomplishment. And man, this, like, this is filthy. You can't, it's maybe hard to see it, but like, yeah, a lot of aluminum powder everywhere. I have to think carefully before I remove this from its stand, because right now it's all like lined up. This is at 0 in the center. This is, yeah, you know, I don't want to mess up any of the persuasion, but I'm checking my list. I'm making my list and I'm checking it twice. And it looks like I can pull this off of its stand. I'm just going to make sure. And then I guess the next time I talk to you, I'll be at the lathe. Well, I didn't want to go too much farther without checking in with you. Hang on, let's do this. And we'll take a look at this. So here is my future Mercury suit wrist rings sitting as a monolithic billet of aluminum. And what I did was I started with a 1/2-inch drill. And then in 1/4-inch increments, I went 1/2 inch, 3/4, 1 inch, 1 1/4, 1 1/2, 1 3/4, and 2. And now I'm using this big fat boring bar, and I'm just slowly removing the interior radius of this until it's going to be as the internal diameter is what I want it to be for the wrist rings. Once I have that, then I'm going to start cutting these off. And again, I'm hoping to get 4 or 6 out of this. We'll see. My wrist, the boring out of the middle of my wrist rings is almost complete. It took some doing. This big honking chunk of aluminum, I probably could have gone with some thick wall pipe, but I had the stock. And so I decided to go with this stock. But at a certain point, so I was peeling it off beautifully using this little, there we go, this little high-speed steel tool. I was taking off about 1/4 inch in a pass, and it was going fantastically. And then all of a sudden, it started just shattering like, oh, and just was terrible. Oh, yeah, the whole thing was ringing. And I fixed it with a couple of things. One was I realized I didn't have enough grabs, so I added some wooden wedges here under the jaws because I was a dummy and I'm only grabbing with this bottom part. And then I added some rubber bands here to help kill the resonance. That was a tip Victor Broadley gave me when I texted him.
Someone is at the front door.
Someone is not at the front door. Alexa is lying to me. But I'm about to make the final pass for the interior of this, I think. Yeah, it's almost, yeah, it's very close to the final pass. And then it's going to be time to start cutting these off. There's still a bunch of finishing to do, and I'm going to tumble these parts, but yeah. 2 days so far, man. This is fairly involved. You can tell my hair is crazy. All right, here we go. So now I have the interesting challenge of cutting slices off of this guy and not having it chatter. And that's where a very specialized piece of equipment I own comes in. And it's this. This is a bullnose rotating center. And it will go in my steady rest, my tailstock. And it will allow me to hold on to this thing and be really nice and rigid about how I'm holding on to it. There we go. Look at that. Okay. Whew. I'm excited about this part. I have just cut off the first wrist ring, and on a cursory glance, it's not bad. It's not amazing, but it's not bad. Got my 11 clusters of 3 triangles each that are roughly 230 thousandths across, about 100 thou high, plus my button activation, plus the interior diameter of this is exactly 3.5 inches, which will fit this tubing, which will help connect to, yeah. I may get 6. I'm shooting for 6, but I may only get 4 of these, but we're shooting for 6. Here we go. Oh, it's pretty. Look at that. Yeah. Okay. So the next step with these is I'm going to tumble them in my ceramic media tumbler. That's the next step. And then I managed to get 2 sets of wrist rings. That's enough for both of my Mercury suits. And I'll make a mold of this to share with other of my fellow Mercury suit makers, because none of us has made this wrist coupling yet. I mean, I probably could have bought like 1/4 inch thick wall, 4-inch diameter tubing. That probably would have been a lot easier. Woulda, coulda, shoulda, right? I'm going to set up my tumbler, and then I'm going to get to sanding and doing some finishing on these final parts as well. Okay, guys. I had hoped that this would be a one-day video. It is so not a one-day video. It's not even a one-part video. In fact, it's cutting so long, we decided to stop it here and cut the rest of it into a second video. But make sure we're all on the same page. At this point, I finished 4 connectors. I was hoping for 6, but I ended up with 2 pairs, 4 of them. And I'm really, really happy with how they look. I'm never going to machine this part again. So I'm very pleased with how they are. And in the next video will be how I finish these. I want them to look and feel like genuine, dyed-in-the-wool, 100% USA NASA parts. And in order to achieve that specific type of look, I'm going to bring in a brand new piece of equipment you guys haven't seen before. And I don't know if I've even talked about it very much before, but that should be a specialized thing for the next video. For right now, thank you guys for watching this video, and I will see you next time. Thank you guys so much for watching that entire video. If you would like to support Tested even further, well, I'm here to tell you that you could become a member. If you follow the links below, you will see there are several tiers of membership depending on how much you'd like to pay and how much access you would like to me and the Tested team. And membership comes, as always, with some excellent benefits, including questions that I'll answer in live streams. The questions have been so amazing, and exclusive videos and exclusive content. Follow the links below, and we will see you next time.